Okay, well, we're jumping right on into the formal definition of the limit, which was stated in the previous video. And so what I've done here is I've kind of filled the theorem out. This was x minus c, if you can remember, and this was f of x minus L. And of course, you see I'm getting that from up here. This is our c, okay, and this is our L, which is 16, and of course our function is x squared. Now we have chosen an epsilon to equal 0.1, so I'm getting close to our limit, or getting close to L, I should say, and I'm choosing 0.1 here. And the idea is we want to find a delta. We want to find a delta. If we're given an epsilon 0.1, we want to construct a delta. And what I'm going to do here is I guess maybe we should just take a look at the graph first. Okay. So this right here is our C, and this is our L, which is 16. So this is 4 here on the x-axis, which I don't have in here, but I think you can barely see it here. But anyway. Alright, an f of x is going to land somewhere between 16 and 16 plus our epsilon, which is 0.1, which is here. So as f of x gets closer and closer to 16, there needs to be an x down here that's getting closer and closer to 4. Now here's the deal. I've come up here, I've got 16 plus 0.1. Now, for what x value can I plug in to our function that would give me out 16.1? And this is what we need to find down here. Okay, so let's go back and look at the algebra. So, dropping the absolute value bars, we end up with x squared minus 16. We're trying to find the solution set for x here. X squared minus 16 has to be less than 0.1, which is our epsilon. And then what we do is we flip the sign and then make this a negative 0.1. And then we come down here, or over here, I mean, and bring the 16 to the other side, so it becomes 16.1, and because this is square here, we want to square root it. Now we're going to use the plus, not the minus side of this. And so this says that x has to be less than the square root of 16.1. And of course this one here says that x must be greater than the square root of 15.9. But to get our delta, that's the difference. Let's go back to the graph. Okay, so delta is this difference here. So here was our square root of 16.1, and to get this difference, right, we take the larger number minus our 4 here, and that's going to give us our delta. And then of course I do the same thing over here. Now you'd probably think that both these deltas would probably be the same, but they're not. Okay, they're not. And so to find this delta here, we take the larger number, which is 4, minus, and then this piece right here, which is the square root of 15.9. Now it turns out, and I think I've kind of exaggerated this, even though it does look kind of correct here, but it turns out that this delta here is smaller than this delta. We want to choose this delta, the smaller delta. We have to choose the smaller delta, because if we choose this delta here, that means, if you can imagine, I'm coming out this far over in this direction, right, from here to here. If I chose an x, let's say here, right, then the f of x is outside of this interval, right? So we have to choose an x so that it stays within the interval, okay? Another thing, this is the largest such delta we can choose. We could choose actually a delta just smaller than this delta here, but it can't be any bigger than this delta. Right? So I hope you understand why we're not choosing this delta and we're choosing this delta here.